Welcome to today's lesson. I'm Siamasaka Kendens, and so today I'm going to take you through a lesson on a speed time graph. And so it goes straight into the lesson for today. Well, we will actually look at a speed time graph, and we'll basically calculate an equation that solve a question that is presented before us. It reads as follows: a car accelerates uniformly from rest at 5 meters per square seconds for 20 seconds, and it maintains a steady velocity of 30 seconds, and it is then brought to rest in 10 seconds under uniform retardation. Calculate the total distance traveled by the car. Number 2, calculate the deceleration of the car. Basically, when we are presented with the equation like this one, we have to look at the concept that pertain to a speed time graph. Basically, a speed time graph, actually the area under the curve actually gives us the distance traveled. And so we will actually, the first step that we are supposed to do is to write the title of the graph, which is actually a speed time graph. And then the second part that we need to go into is actually to draw the actual graph and label it. So it has actually the y-axis, which is a straight line, and then the x-axis. So we label it. We have the time in seconds, and then we have the speed in meters per second. And we are told that actually the car is starting from rest. So we can draw a straight line. And actually they are saying it took actually 20 seconds. Okay, so we have our 20 seconds there. What we don't know is actually the final velocity. And so we have to calculate this final velocity, since we are given that the acceleration is 5 meters per square seconds. So for us to find the final velocity, we can calculate the acceleration, and we know that acceleration is equal to final velocity minus initial velocity over time. And so we know that this is 5 meters per square seconds, and the final velocity is the one we're looking for. And our initial velocity is actually 0 meters per second, because the car is starting from rest, and it took actually 20 seconds. And so when you are presented with an equation like this, we can merely cross multiply because we are going to have 5 is equal to v over 20, and then we can cross multiply. And so we can get our final velocity to be 5 multiplied by 20, which is equal to actually 100 meters per second. And so we have found our final velocity, which is actually 100. And we are told that actually the car maintains a steady velocity of for 30 seconds, meaning that it had a constant velocity for 30 seconds. So the car moved for 30 seconds steady, meaning that the velocity actually was uniform for 30 seconds. And if we add 30 seconds to 20 seconds, it gives us actually 50. It means that the car would have covered 50 seconds from zero actually. But from 20 after 20 seconds it covers 30 seconds. We are told that actually the car then was brought to rest in 30 seconds under uniform retardation, meaning that it goes back to zero with the uniform retardation, straight line, and this actually did that in 10 seconds. So if you add 10 seconds plus 50, it gives actually 60 seconds. And the first part of the question they are saying, can we find the total distance traveled by the car? So when we are presented with such a situation, actually we said earlier on that on a speed time graph, the distance covered is actually equal to the area under the curve. And so under this triangle, you can call this one as distance 1. And under this triangle, rectangle, you can call it as distance 2. And under this triangle again, you can call it actually distance 3. So when you add these 3 distances under the curve, then you would have calculated actually the total distance covered by the car. And so we will start by looking at the area under the curve, which is actually for the triangle, which is distance 1. Since it's a triangle, right angle triangle, so it will be half base multiplied by the height, which is equal to half multiplied by, if you check our base here, is actually 20 seconds. So we have 20 seconds multiplied by height, which we said it is actually 100 meters per second. Note that here actually seconds here and this one are going to cancel. And 2 here is 1, and 2 there is actually 10, which gives us actually 1000 as our distance 1. So distance 1 will be equal to 10 times 100, which is actually 1000 meters. So meaning that we have found actually the distance for the car to move from rest to a point where it has covered 20 seconds. Now we need to find the distance covered by the car from 20 seconds to 50 seconds, that is in 30 seconds time, and that is when the actual velocity was constant, which we have actually denoted by distance 2. And so we can say distance 2 is equal to the area under the curve, which is length multiplied by the height. And we know that the length is actually 30 seconds multiplied by the height, which is 100 meters per second. And as we stated earlier, we can actually cancel out this second and that second. And this gives us actually 30 times 100, which is actually 3,000 meters. So the distance covered when actually the speed was constant is actually 3,000 meters. And then now we can calculate the distance covered when actually the object was decelerating. We have denoted it by distance 3, which is the area of a triangle, which is a half base multiplied by actually height. And we are aware that our base is actually 10 seconds. So our base is actually 10 seconds multiplied by the height, which is 100 meters per second. And again, we note that here actually this second and this second are going to cancel. 2 here, 1, 2 there, actually 210 is 5. And so we find that actually distance 3 is 5 times 100, 5 divided by 100, which is actually 500 meters. That is for distance 3, which is the distance under the curve when the car was actually decelerating. So our overall distance will be equal to distance 1 plus distance 2 plus distance 3. Remember, distance 1, we found that it was 1,000. It was 1,000 meters. So we got 1,000 meters plus distance 2, it was 3,000 meters plus distance 3, it was actually 500 meters. So the total distance that we find is actually 4,500 meters. So this is actually how we can calculate the distance covered by the car. We merely find the area under the curve for the two triangles as well as the rectangle. And then the last part of the question is actually to find the deceleration of the car when it was brought to rest in 10 seconds under uniform retardation. So all we need to do is merely actually to calculate the acceleration. I'm going to calculate it here. So acceleration is equal to final velocity minus initial velocity over time, which is equal to final velocity 0 meters per second minus the initial is 100 meters per second over actually the time taken. We saw that it was actually 10 seconds. And you notice that what we get here is actually negative 100 divided by 10. And this gives us actually our retardation to be equal to negative 10 meters per square second. And so this is actually how we can calculate the retardation. That is when the car was moving with uniform retardation in 10 seconds. So those who are interested in one-on-one lessons, actually, you can contact me on my WhatsApp number, which is 260-977-4199. This is my WhatsApp number. So if you want lessons one-on-one, you can actually contact me using this number. And so I thank you.